We are back with some unexpected examples for our Solutions 101. I did not list a part 3 in your notes, or sorry, in your agenda. So these are kind of supplementary problems that you can use to help you with the worksheet. And it's to support your understanding on the assignment of AP Solutions Worksheet 1. So we're going to do 3 examples. Here, our first example is going to be if 25 grams of calcium nitrate are dissolved in 500 milliliters of solution or water, what is the concentration in molarity? Okay, so we have 25 grams of calcium nitrate dissolved in 500 milliliters of solution, and we want to know what's the concentration in molarity. So we're going to go back to our equation. Molarity equals moles of solute per liter of solution. And we want to identify that our solute here is the calcium nitrate. So what we have to do first, of course, is convert to moles. So our job is going to be to take 25 grams of the calcium nitrate, and we are going to convert to moles just to see how many moles we are dissolving. So just give me a minute and I will have the molar mass. And that molar mass comes out to be 164.086 grams per mole. And then we're going to divide 25 by that number. Oh, whoops. So we're going to do 25 divided by 164.086. And we get 0.152 moles of calcium nitrate. So that would be the top part of our expression, the moles. So that's going to go here. And then the liters of solution we know to be 500 milliliters. And we know that for every 1,000 milliliters is 1 liter, which means we have 0.500 liters of solution. And so our molarity we know is moles per liter, and so we're just going to substitute 0.152 for the moles and 0.500 for the liters, and we are going to get 0.304 molar. So you show a capital M there for your molarity. So we'd say that's 0.304 molar calcium nitrate, and that would be aqueous, which is meaning that it's dissolved in water. So that's our first example for finding molarity. And our second example is going to go off of the first example. They're not always going to be connected, but just for ease of work, we're going to do, from this example, we're just going to use some of our numbers. And so example 2 is going to ask how many grams of the calcium nitrate are found in 350 milliliters of the above solution. Okay, so we have 350 milliliters of this solution with a certain concentration. We know the concentration, excuse me, is 0.304. And if we want to find grams of the calcium nitrate, of course we have to know the moles first. So we're gonna do just kind of a big picture here. If we want grams of the calcium nitrate, we first have to go by way of moles. And the moles come from the molarity times the liters. I kind of did that backwards, but hopefully you get the idea. We're going to do molarity times liters first, get to moles, and then we're going to go from moles to grams. So, we know moles equals molarity times liters, and we're going to do 0.304 for the molarity, and the liters is going to be 0.350, and I changed the milliliters to liters without showing you the conversion factor, but I'm going to assume that you know how to do that. So we get 0.1064 moles of calcium nitrate. And so pretty easy from there. We're just going to bring this down. 0.1064 moles of the calcium nitrate. And we're going to convert to grams. So that means the mole goes on the bottom and the molar mass on top. And I'm going to reuse my molar mass from above, 164.086 grams per mole. And I will get 17.5 grams of calcium nitrate. So pretty simple, just exercising that relationship that is molarity to find moles. Using the molarity times liters is equal to moles. And then converting to grams, of course. So those are our first two examples. And I'm gonna go ahead and trade pages here. Of course, you can pause me if you need to. And we're gonna go on to our third example. So this is our third example, example 3, and this has to do with dilutions. And we want to remember that with dilutions, when we dilute something, we're just adding water, basically to make it less concentrated. So the solute, the amount of solute doesn't change. So we want to remember that the initial molarity times the initial liters is equal to the second molarity times the second liters. Because moles before are equal to the moles after. That's the solute. Okay, so let's say that we're still back with our 0.304 molar solution. If we dilute 25 milliliters of the 0.304 molar calcium nitrate to 185 milliliters, what will the new concentration be? So let's go through and identify what we know. We are given an initial volume, so this would be L1. We're also given an initial molarity, so this is going to be M1. And we're given our secondary volume, so that's going to be L2. And the phrase new concentration, we should identify as M2. Okay, so basically this is just a plug in the numbers and chug out the answer, right? So we're going to do M1 times L1 equals M2 times L2. Our M1 is going to be 0.304. Our L1 is 25 milliliters. And I'm gonna go ahead and change that to liters. If they're both in milliliters, you can actually leave them in milliliters, but for teaching purposes, I'll go ahead and change it. And then our unknown is our M2, and our L2 is 0.185. And then of course, we're just gonna do some baby algebra here. Divide by 0.185 on both sides, and that's gonna give us our M2. So we'll go 0.304 times 0.025, and then divide by 0.185. And we get M2 is equal to 0.0411 molar. Okay, so we want to check and make sure, does this make sense? We're going from a small volume with a larger concentration, and we're adding water, so we would expect for the concentration, the second concentration, to be lower than the first concentration. And we started at 0.304 and we ended up at 0.0411. Okay, so that makes sense. The concentration went down. So that's an example of where you're solving for M2. If you're asked for how much of one substance do I need to add to this to make a certain molarity, then you're going to be looking for your L1. So be on the lookout for questions like that, and we can answer problems in class as well. So those are our 3 examples. Thank you for watching, and that's it.